Software Engineering the Future, a deep dive into software development, understanding the foundations of software engineering. Software engineering is the backbone of modern technology, enabling the creation of everything from mobile applications to complex systems that drive industries worldwide. At its core, software engineering is about designing, developing, and maintaining software that is reliable, efficient, and scalable. Whether you're a budding developer or an experienced engineer, understanding the foundational principles of software engineering is essential for building robust and high-quality software.
Development methodologies. Software engineering embraces a variety of methodologies, each with its own approach to how software development should be organized and managed. The most widely adopted methodologies include waterfall, a traditional linear approach where each phase of development is completed before moving to the next. It is best suited for projects with well-defined requirements and little to no change. Agile, a more flexible, iterative approach that emphasizes collaboration, customer feedback, and rapid delivery. Agile methodologies such as Scrum and Kanban focus on delivering small, functional increments of software regularly, allowing for changes and improvements based on user feedback. DevOps, a methodology that emphasizes collaboration between development and operations teams. It aims to shorten the development cycle by automating testing, deployment, and monitoring processes, ultimately improving software quality and delivery speed. Lean focuses on delivering value to the customer with minimal waste. Lean principles emphasize optimizing the flow of work, eliminating non-value-adding activities, and continuously improving processes. Each of these methodologies offers a different approach to managing software projects, and choosing the right one depends on the project's scope, complexity, and the team's preferences. Challenges in software engineering. Despite the best efforts to follow software engineering principles, the field is not without its challenges. Some common obstacles faced by software engineers include complexity. As software systems grow in size and scope, they often become more difficult to understand, maintain, and scale. Managing complexity is one of the key challenges in software engineering. Changing requirements. Requirements often change throughout the development process, either due to evolving customer needs or shifts in the business environment. Software engineers must be adaptable and flexible to accommodate these changes. Quality assurance. Ensuring that software is free of bugs and vulnerabilities while meeting performance expectations requires rigorous testing and a commitment to quality. Time and resource constraints. Software development often needs to be completed within tight deadlines and budget limits, requiring engineers to make trade-offs between quality, features, and time to market. Overcoming these challenges requires a deep understanding of software engineering principles, a willingness to learn, and the ability to think critically and problem-solve effectively. Software engineering is a multifaceted discipline that requires both technical expertise and a strong understanding of design, development processes, and project management. By mastering the foundational principles of software engineering, engineers can create software that is not only functional, but also efficient, reliable, and scalable. Whether working on a small mobile app or a large enterprise system, understanding the core concepts of software engineering is essential to building high-quality software that can meet the demands of users and stakeholders alike. As the field continues to evolve with emerging technologies like artificial intelligence, machine learning, and blockchain, software engineering will remain at the forefront of shaping the future of technology. Agile methodologies. Best practices for developers. In the world of software development, agility has become a key factor in ensuring the rapid delivery of high-quality products that meet user expectations. Agile methodologies focus on flexibility, collaboration, and iterative progress, making them ideal for today's fast-paced development environments. But implementing Agile successfully requires more than just following a set of rules. It demands a mindset shift and adherence to best practices that help teams navigate complexities while delivering value. This article explores some of the core best practices for developers working with Agile methodologies to ensure effective and efficient project delivery. 1. Understanding Agile, the basics. Agile is not a single methodology, but a set of principles aimed at improving the flexibility and efficiency of software development. The Agile Manifesto, created in 2001 by a group of software developers, outlines core values and principles, emphasizing customer collaboration, working software, and responding to change over rigid planning and contract negotiation. Key elements of Agile include iterative development. Work is completed in small, manageable chunks, known as sprints, which are typically 4 weeks long. Collaboration. Teams work closely together with frequent communication between developers, designers, stakeholders, and customers. Continuous improvement. Agile encourages regular reflection and adaptation to improve the development process over time. Customer-centric approach. Agile places a heavy emphasis on delivering value to the customer with every iteration, rather than focusing solely on deadlines and feature lists. Several methodologies operate under the Agile umbrella, including Scrum, Kanban, and Extreme Programming XP. Each has its nuances but shares the core principles of Agile. Write testable and maintainable code. In Agile, the focus is on delivering working software in each iteration, which is often tested continuously. Therefore, it is crucial to write code that is testable. Write code with automated testing in mind. This includes unit tests, integration tests, and acceptance tests to ensure code quality throughout the development process. Automated testing makes it easier to detect issues early and reduces the risk of bugs in production. Maintainable. Code should be clean, well documented, and easy to refactor. Agile projects tend to evolve quickly, and the ability to make changes without introducing new problems is key. Maintainability is also critical for enabling future updates and scaling the software. Tools like JUnit, TestNG, Selenium, and Jest can help developers implement automated testing frameworks in their Agile workflow. Focus on small, deliverable features. In Agile, work is divided into small, manageable units, typically called user stories or tasks. Each user story represents a feature or functionality that delivers tangible value to the customer. These features should be small and incremental. Break down large features into smaller pieces that can be developed and tested within a sprint. This allows teams to deliver value quickly and reduce the risk of scope creep. End to end. Focus on completing a feature from start to finish, including coding, testing, and integration. This ensures that every feature is usable and doesn't just exist in isolation. Testable in isolation. Each feature should be independently testable, which reduces complexity and enables more efficient bug tracking and fixes. Breaking work into small chunks also facilitates more accurate estimation and quicker delivery, which is central to the Agile approach. Participate actively in Scrum ceremonies. Agile teams typically operate within a framework like Scrum, which includes a set of predefined ceremonies to keep the team focused and organized. Some of the key ceremonies are daily stand-ups. These short meetings, typically 15 minutes, are essential for tracking progress and identifying blockers. Developers should actively participate by sharing what they have done, what they will do next, and what challenges they are facing. Sprint planning. Developers should be actively involved in sprint planning meetings to provide input on how to approach tasks, estimate effort, and identify dependencies. Sprint retrospective. After each sprint, the team reflects on what worked well and what could be improved. Developers should be open to feedback and suggestions for process improvements to increase efficiency and collaboration in future sprints. By participating actively in these ceremonies, developers can stay aligned with the team's goals, collaborate more effectively, and continuously improve their workflow. I'm Edson Camacho, a software engineer. I hope you enjoyed this content on the future of software development. If you did, please give this video a like and subscribe to the channel so you don't miss any future updates. Your support helps us bring you more insightful content. Thanks for watching, and I'll see you in the next podcast.